So let's say you're given this diagram of a mass connected to a long stick, applying a force of 500 newtons on the end of it. Can you tell me the magnitude and direction of the torque at point P? If not, let's look at this problem together. So we can start by remembering how to find the torque. So torque is equal to R cross F, where R is just the vector from the origin to where the force is acting. And that'll be more clear when we look at the diagram, how to identify that. And then F is just force and T is torque. Note, to find the direction of the torque, you must use the right-hand rule since it's a cross product. And I have a video explaining that. If you don't remember the cross product, you can just look back a few videos. But for example, if we have the R cross F here, we take our right hand and curl our right fingers pointing from R to F, and your thumb will point in the T direction. So if you do it properly, your thumb should point in the same direction as the T vector that I drew on the diagram. So now we can apply this back to our example. This is our example problem here, and we can start by identifying our givens. This is clearly going to be our R vector because we can see that from the point, we just draw a vector pointing towards where the force is acting, and the result will be that vector there. The R vector is equal to 0.8 meters. We can identify that the force is equal to 500 newtons. We need to find the torque. So first thing we can do is look at identifying the direction. So we can remember that the equation is R cross F. So we're going to be crossing from R to F. So we can draw the diagram like this, making it more clear what the angle between them is going to be. We identified that angle as phi. We can use the right hand rule to find the resultant vector. So if we curl our hands from R to F, we can see that the torque is going to be pointing up out of the page. That's going to be our answer for the direction. And now we can start looking at the magnitude. If you remember the cross product, we can also write it in this form where it's equal to RF sine phi, where R and F are just the magnitudes and phi is the angle between them. If we look at our diagram here, we can identify that we need to solve for phi, which is the angle between them. So if we use some trig, we can use that any right-hand triangle is equal to 180 degrees, and then we can find this angle here. And then we can identify that this larger angle is equal to 180 degrees. So if we just subtract 71 from it, we'll get phi. If we do that, we get phi is equal to 109 degrees. Now we can plug everything in that we have, and we get this expression here for the torque. And I also want to note this symbol here just means pointing out of the page. And if we do this calculation, we get the final answer that the torque is equal to 680 Newton meters pointing out of the page. I just want to note this would be the force of torque felt at point P, produced by the force in the distance R.